Good evening, sir.
Good evening. Test marks have come.
Yes, sir.
No, test marks have come.
Yes, sir.
How much did you get in physics?
In physics, I got 165.
Okay, five more than expected.
Really?
Five more than expected.
Oh, okay.
Yes, ma'am. So, what should I discuss today?
Uh, they started motion in a plane vectors chapter.
Relative motion.
Relative motion, they finished that.
Just one minute. Ah, yeah, ready.
Okay.
So vectors they just started, is it?
Yeah.
Okay, so you have any questions, problems to solve, or
No.
uh, okay? This relative motion, should I discuss? 1D motion,
Yeah, we can do that.
yeah, but that is slightly involved. Usually the frame, uh, we'll consider the frames which are at rest or uniform motion. You know what's uniform motion, right?
Yeah.
What is uniform motion? It's moving with the
It,
constant
it constant.
velocity.
It shows a constant value velocity.
Yeah, so if the frame is like this, X, Y, Z. So this frame can move with a constant velocity, say 2 meters per second, and this 2 should be constant throughout. It should not change. So the frame can come here like this. Okay. Another thing is the frame is at rest, that is velocity is 0. Okay. So now we have two frames. Say one is moving 2 meters per second. Another is say moving at 5 meters per second, say towards right only. And the third frame here, which is at rest.
Yeah.
Okay. So now we have a body, say a car. Okay. So it's moving with let me put some arbitrary number, say 10 meters per second. Okay. So this is velocity of the car with respect to the ground. That's by default. If you don't put anything, it's with respect to the rest frame or the ground. Okay, this is the same as the earth frame because we are assuming earth is not moving. Okay, so this velocity of car, let me call this frame as A and this second frame as B. Okay, and so velocity of the car with respect to A frame is how much? Simple
Velocity of
logic.
car with
With respect to A, simple logic. Car is moving with 10 meters per second, and A, the frame is moving 2 meters per second towards the car. So obviously the speed of the car will be less by an amount of 2. So it should be 8 meters per second. Is that clear?
okay. Yeah.
Simple logic, no? See,
Yeah, if both are going in the same direction.
yeah,
Okay.
okay. Now the velocity of the car, this is the notation. Velocity of C with respect to A. Okay, so with A as reference, what is the speed of the car? Similarly, velocity of the car with respect to B frame is how much?
Velocity of car with respect to wave frame, which is
Huh,
5 minus 10, 5 meter per second.
yeah, 5 meters per second. So suppose I have a frame C. Okay, let me call it D because C is already there. Frame D, which is moving with a speed of 10 meter per second towards the right. Now the velocity of the car with respect to D is how much?
What, sir?
D frame is there, moving the 10 meters per
Yeah.
second.
Then velocity, total velocity zero.
Zero. So that's equivalent to rest. Okay, in some sense, so rest is a relative concept. It depends on the frame. Whatever is happening as rest in one frame, it will be in motion in other frames. Okay, suppose I have a frame, uh, E, E frame, say it's moving towards left with say 3 meters per second. The velocity of the car with respect to E frame is how much? Tell the answer.
Velocity, see, we add both of them, 13 meter per second.
20 meters per second. Because the distance is increasing because of the car moving and also the frame moving. So the movement of the frame is going to increase the distance between the car and the frame in the same amount of time. So it's as if it's moving faster. Okay, so from this we can conclude the vector relation. Velocity of the car with respect to frame is velocity of the object, here car, minus velocity of the frame, in this particular case E frame. Okay, so this is the relative velocity formula, or what you can say. Okay, so to take the
Sir.
direction. So in 1D motion, the direction can be taken in terms of sign. So one direction is positive, other direction is negative.
Okay.
Okay. So here I have taken this example of three people, A, B, and C. A is moving towards right with
Yeah.
speed of VA, and B is moving towards right with speed of VB, and VC at rest. So velocity of B with respect to A is velocity of B minus velocity of A, and the velocity should be with the sign. Okay, in 1D motion, one direction is positive, other direction is negative. So this is a, you can say, definition of relative velocity. Okay, so now these two bodies, say A and B, could be two cars. Okay, so this is the XT curve. So from this, just looking at the curve, what can you understand about this moving objects? What is the velocity of A? Is it constant, uniform?
Velocity of A. Yeah,
Uh,
it's constant.
Constant, okay, both are same. Constant and uniform. And the velocity is related to the slope as, so whatever the slope of this curve, that is the velocity of A, correct? And the slope of this curve, slope of B is velocity of B. Okay,
Mm-hmm.
so can you compare VA and VB? Which one is more?
Velocity of B.
No. Slope,
Slope
no.
of B. Yeah, slope of B.
No, no. Slope is same. They're parallel lines. Just that B is starting at x equal to 20. A is starting at x equal to 10. But both are moving at the same speed. So this is the x-axis, origin. 10 is here, 20 is here. A is starting from 10, B is starting from 20, but they're moving at the same speed.
Okay.
This is A and this is B, but the speed is same. So the distance between these two will be constant. Because when A has come here, B will move here, but the distance will be same because the speeds of both or the velocity of both is same, constant. Okay. So here A is moving like this. A is starting from 10 and keeps going on towards right. Trajectory is path of the body.
What, sir?
Trajectory is path of the object.
Yeah.
Okay. So it is start. This is the x-axis. So A is moving like this. I can put an arrow to denote the direction, and trajectory B also I can draw.
Yeah.
Okay, B will start from this point and go towards right. Both are moving at the uniform speed. Okay. Next, this case, A is moving, xt curve of A is this one, xt curve of B is this one. So from this, what can you understand about the velocity of A and B, and you can also draw the trajectory. Draw the trajectory, draw the x-axis, and show the path of the object, which is A and B. First, draw the x-axis. Just try it.
Okay.
Horizontal line. This is x-axis, positive direction, say. Somewhere origin is there. Draw the trajectory of A and B on this line. Try it. A is starting from which point? From the graph. At t equal to 0, x of A is how much? X is how much?
H is equal to,
Approximately 10, right? It's looking in the middle.
yeah, yeah,
Okay. And it's moving with some velocity. Here in this curve, which one is steeper? VA or VB? V is the slope of this curve, VB is the slope of this curve. Which curve is steep? A or B?
V,
A line which is vertical is more steep.
yeah.
Okay. So VA is greater
So
than
V of
VB.
A,
VA is more.
yeah, V,
Okay. And VB is less steep. So start at 10. So mark 10 in the x-axis. So this is
okay,
10. Okay. So trajectory of A look like, draw it. So start from 10 and move like this.
okay,
This is A. Okay. Similarly, B. What is the starting point of B? B is starting at 40. So this is 20, 30, 40. So this is 40. So from this thing, we'll move towards right. This is 40. Okay. But A is moving at a higher speed. So even though A is behind, at some stage, say B is here, both will catch up. At some stage, B would have come here. At the same time, A would have come here. That's possible, no? Because VA speed is more. This moving at
yeah,
higher speed, this moving at lower speed. Okay, so even though A is behind to start with, since it's moving with higher speed, it will catch up. And that catching point is this one.
yeah,
At this point, X is same. For both, it's around, say, 70 or 65, you can say, less than 70. So this much where it's catching up, that X value is, say, 68 approximately. Okay. After that, A will overtake. So after this point, A will be like this, and B will be here. Sorry, B will be behind. B will be here. A will be here. Is that clear? Okay. Is this clear? Your mic is off.
sorry. What, sir?
No, is this clear?
Yeah, it is.
So, what is the difference here in this figure, A and B? Similarly, draw the trajectory. Initial point of A, initial point of B, and then draw the trajectory.
Yes, sir.
Just a minute. So this is my x-axis. Okay, so my origin is there. So initial point of A is how much? 10. And then it's again starting at 40. So this is 10 meters. This is 40. Okay. So draw the trajectory of A. So starting from 10, it's moving towards right or left? A is starting from 10.
From right to left.
It's moving towards right because velocity
Left
is
to right.
positive. But B, starting from 40, it's moving towards
Right to left.
left. Just say left. Okay. So this is B motion. This is A
Okay,
motion.
sir.
So somewhere here they will meet. Right? Because A is starting from here and B is starting from here. So obviously they will cross somewhere. After that, A will go ahead in the right direction. B will go ahead in the left direction. So that meeting point is x equal to approximately 30. Let me make it 30 itself. Okay, so 30 is somewhere here. So looking at this curve, slope of which one is more? Okay, looking at the intersecting point 30, which is 20 meters away from initial point of A, but 10 meters away from initial point of B. So which one is moving faster, A or B? Just the magnitude. Your mic is off.
Sorry.
Magnitude wise, VA and VB, which one is more?
Magnitude is VA.
Because VA has moved a distance of 20 meters in the same time. So VA magnitude is greater than VB.
VB magnitude.
But VA is positive, VB is negative. Okay, that's the sign we can consider separately. Okay, but yeah, one more thing is I can actually get the slope from this thing itself. Suppose I take this convenient point. Okay, fine. That also I can do. But from the meeting point also I can get the information that velocity of this thing is. So here the velocity of relative velocity of A with respect to B, it will be VA plus VB magnitudes with the moving opposite directions.
Okay.
Okay. Okay. Solve this example. Two parallel rain tracks run north to south. Train A moves north with speed 54 kilometers per hour. B moves south 90 kilometers per hour. So B is moving faster, but it's moving the opposite direction. What is the velocity of B with respect to A? Velocity of ground with respect to B. All simple this thing. Okay. Solve the first part, A part.
It's 45.
Okay. Don't skip the steps.
No, 45. No. Sorry.
Just a minute. So velocity of B with respect to A is velocity of B minus velocity of A. Velocity of B is 90 towards south.
36, sir.
So south I will take it as negative.
Yeah. Yeah.
Okay. So it's minus 90 plus and then VA.
Plus 36.
No, 54. Just keep it in
No,
kilometers per hour.
minus 36. Minus 36.
Why minus 36? I'm taking north direction as positive.
Should
North,
be as past. Okay, minus into positive. Okay, that's what doing.
since they are going opposite
144.
directions, the relative velocity will be more. So both of them will add. So minus 1.
Minus 144.
That's why I say don't skip the steps.
Okay.
Okay. So this they have converted to. Hey, I made mistake. Velocity of velocity of B is with respect to A. Train is moving north 54. B is south 90. Okay. North direction is positive. What is the velocity of B with respect to A? They're moving opposite direction, so they'll add up 144 only. They made mistake in the book. Okay, VA is positive, north is positive. Okay, meter per second. Fine. It's adding up only. 15 and 25, they add up to give 40. Okay, they're converted to meter per second. Your mic is off.
Yeah, kmph
Ah,
converted to meter per
ah.
second, yes.
So it's adding
So the
only.
final answer you got, can you just convert it into meter per second?
Yeah. So 54 and 90 are good numbers because they will 54 will become 15 and 90 will become 25. Okay. So relatives will add up because they're moving in opposite direction. So it will be 40. And VB minus VA, so VB is negative. So this thing will
40
be
meter per
minus.
second.
Okay, B part, velocity of ground with respect to B. Velocity of ground with respect to B is velocity of the ground, which is 0, minus velocity of B, which is minus 90. So plus 90 kilometers per hour, so it will be 25 meter per second. Correct. Clear? Mic is off.
Yes, sir.
So the third part, the velocity of the monkey running on the roof of a train against its motion with a velocity 18 kilometers per hour with respect to train A as observed by the man standing on the ground. Yes. Try it. C part. So this 18, okay, you get the answer. Let me check.
Okay. Which question again?
Got the answer?
C question, no? B
Sorry.
question. B question.
10 meter per second. See, first thing you have to understand is what this 18 kilometers per hour with respect to the train. So whatever is given as 18, that is velocity of the monkey with respect to A.
Okay.
Velocity of monkey with respect to A is 18. See, suppose you have the capability of running at 10 kilometers per hour. Suppose you're running on ground, you will be moving the speed of 10 kilometers per hour in the ground. But suppose you move around, going the same speed on a train, on a running train, so that 10 kilometers per hour will be with respect to the train. Okay. So what was the capability of the monkey, which is 18 kilometers per hour? That's with respect to the frame. So this is 18. So that is velocity of monkey minus velocity of A. So you find velocity of the, another thing is it's E is moving in the positive direction. No. So this is moving in the opposite. So it's minus 18. See, the train is moving north, but the monkey is running towards south. Okay. So this velocity
Yeah.
of the monkey with respect to train is minus 18. That's what's the important thing. It's against the motion of the train.
And meter per second, it's 5 meter per second.
Yeah, we'll come to that. So minus 18. So and velocity of E is 54, right? Plus 54. So velocity of monkey is 54 minus 18 plus 46. So 46 into 5 by 18. Is that correct?
I think so, yes, sir.
46 or 45? 54 minus 18. So become plus 18 plus 36. Is 36? No.
I think so, yes.
Why is it not working? -54 -20 is 34, 36. -36. So -10 is 5 by 18 is simple calculation. So it's 10.
Yes, sir.
10. And sign is plus because this is plus 36. It is plus 36.
But how they got -15, sir? 15. How they got it?
No, final answer is 10 only. This -18, no, because we're moving south.
Yeah.
Just -5. And then this velocity of monkey minus velocity. So velocity of VA take it to the right side, it become plus 15. VA is plus 15, no.
Yes, sir.
VM minus VA is -5. VA will go to the -5, will go to the right side, become plus VA, which is 15.
Okay.
Is that clear?
Yes, sir.
Yeah. So same thing. Suppose I'm firing a gun. The bullet can come out at the speed of say 100 kilometers per hour. Okay. So if I'm firing from the ground, the speed of the bullet with respect to the ground is 100. But if I'm firing the bullet from a car which is moving at 60 kilometers per hour, then that 100 kilometers per hour is with respect to the car. Understood? No? The mic is off.
Yes, sir.
So if a person has got if an athlete has got a capability of running at say 15 kilometers per hour, on the ground he'll run at 15 kilometers. Suppose he's running in the train, that 15 kilometers per hour, that capability will be there with respect to the train. So this is the most complicated 1D motion. They are moving at the same speed. Okay. Second thing is one is having higher speed. So obviously the guy who
Oh,
is coming behind, if he has a higher speed, he'll cross. But suppose in this case, we just one more complication. See, suppose just a minute. Suppose A is here. Okay, it's moving towards right with say 2 meters per second, and B is ahead and it's moving at 5 meters per second. In this case, they will never intersect because B
yeah,
is
okay.
ahead, but it is at a higher moving at a higher speed. So in this
Okay.
case, the graph will look like this. X is starting here and B is starting here. So X is moving like this and B is moving with a higher slope. So
Oh,
these two will never meet on the right side. Okay. But somewhere on the negative time, it could have met. So this is one more complication. Both moving the same speed, so they were constant distance. They are moving in the same direction, but the one who is behind is higher speed. Third complication is this one. The one who is behind is lower speed, so they will never intersect. The distance between them will keep on increasing. Fourth thing is they are moving the opposite direction. So as far as 1D motion is concerned, these are different possibilities. But obviously, we have taken a case where things are moving at uniform speed because it's a straight line. X versus t is a straight line. So slope is constant. So velocity is constant.
I see. Okay, sir.
This problems motion and gravity and all you have done, no? Because just you have to put acceleration as g. That equations of motion, you know, right? V equal to u plus at. these three equations of motion. Okay, and you should know how you get these motion equations. How do you get the first equation? Your mic is off. First
The
equation.
first equation.
How do you
Yeah.
get it? How do you get it?
Initial
Yeah. What are the proof
obtaining
of?
v.
What
Now
are the proof?
acceleration is equal to v minus u by t.
Uh,
Difference in
acceleration.
velocity by t.
Yeah, acceleration change in velocity, which is v minus the initial velocity
Yeah.
v naught, and the amount of
Yeah.
time taken. So that will give me this one.
Yeah.
Okay. What about this second equation? What is the proof of it?
Second equation can be used.
Distance traveled or the displacement is average velocity at a time.
Yeah. Yeah. Yeah.
That's one way to understand it. It's u plus v by 2 into t. And for v, you put u plus at. Okay. That we have just u and then time. So this t to this t will give me t square. And then the half is here. That will become half here. Okay. What about this last equation? What is the proof of it?
Proof of that. V square minus u square 2as.
Ah. So you can square first equation both the sides. So v square equal to v naught square. And then v naught square plus 80 square plus 2 times. Okay, if I square the first one, I'll get v square equal to v naught square plus a square t square plus the cross term 2 v naught at. Okay, so then I'll take this divide by v square equal to u square plus yeah. So here you take t outside. No, 2 outside. Just take 2 outside. So it'll become 2 ut and here will
Yeah.
become half a t square. No, take 2t outside. So this is v naught square plus take 2t outside. It will become, sorry, not 2t, 2a, 2a outside. It will become vt plus half a t square, which is nothing but x. Is that clear? Mic is off.
Understood, sir.
Yeah. So in the case of, so this is the important assumption here is acceleration is constant. It does not change with time, just a number, a real number. Okay, it's constant and uniform. So these three equations of motion are valid for acceleration being constant. So the acceleration, if AT curve for this equations of motion will be either positive or negative. Two cases.
Otherwise, no value.
No, there is some value.
But the
Some, it can be positive or it can be negative. Two cases. Or it can be zero. Zero is a trivial case.
yeah.
Okay. So in the case of gravity, you just have to put A equal to G or minus. It depends on the direction. If you take upward direction as positive, acceleration is minus G. Okay, just read this question. A ball is thrown vertically upwards with velocity 20 from top of a multi-story building. The height of the point from where the ball is thrown is 25 meters above the ground, from the ground. A, how high the ball will rise. B, how long will it take for the ball before it hits the ground. A simple question.
Yeah.
Understood the question?
Yes, sir.
Get the answer. Got it? Your mic is off.
See, is the answer 1 second time taken?
Okay, what about the height? A part?
The height part,
No, time is not 1 second. Do it again. You have to take the total time to go up and come down. First, draw a small diagram.
Oh, wait.
Your diagram should look like this. From A, you go
Yeah,
up.
I did draw like this.
Yeah, you need the full time.